Hello and welcome to the AWS Certified Cloud Practitioner training. This is the last session. So 2 weeks of training and you should be able to clear the AWS Certified Cloud Practitioner with that. A little bit about myself, Anant Thirumanur. I have 3+ years of AWS and 3+ years of Google Cloud experience as well. I'm a Google Cloud Certified Professional Cloud Architect, and I also cleared the AWS Cloud Practitioner Certification recently. Let's look at what the domains that you need to know for AWS Certified Cloud Practitioner. 26% of the questions come from cloud concepts, 25% come from security and compliance, 33% from technology, and 16% from billing and pricing. So we covered all these topics in the last 9 sessions. Today, we'll be going over a lot of sample questions and trying to understand how to answer them, how to eliminate the wrong choices when you get confused, what kind of techniques you use, and what are things you might have to remember to actually make the right choice. As always, our channel is Top Tech Gurus. Don't forget to subscribe, hit the like button. The first question you're going to look at is about AWS infrastructure in a test environment. You wish to deploy AWS infrastructure in a test environment. When testing is successfully completed, you wish to deploy equivalent infrastructure in production as well. So you have an environment set up in test. You want an equivalent environment, probably not the same exact, pretty similar environment in production. The environments include a VPC, a load balancer, compute instances, and a database. Which AWS service can be used to provision these environments? The options are CloudFormation, which if you know about CloudFormation, I think you should be thinking about what it does and whether it answers this question, but we'll keep it aside for now. Amazon Cloudfront. Cloudfront is an edge, like where you have a lot of edge locations worldwide, and people can, and all your images and videos are cached in those locations. So people like accessing those files from any place in the world are able to access it quickly. For example, Netflix uses edge locations a lot. So that's an example where people around the world watch the same videos, but if you host it in a different place, you can cache it everywhere around the world in edge locations, and that can help the people visiting it from worldwide get it much quicker. Code deploy is used when not for code, but for not for infrastructure, but actually for code. So when you have code and you want to deploy it, like you can use the AWS code build to actually build the code and then deploy the code onto a test region, a production region. But yeah, main difference is this has to actually do with your Python code or a JavaScript code, not the infrastructure itself, not the VPC, not the database, not the compute instance. So can't be number 3. Amazon RDS is a database service. Database as a service for RDBMS kind of databases. So can't be that as well. It has to be CloudFormation. And if you know CloudFormation is a tool where you can have infrastructure as a code. You can write a text file or a short like Ginger template, and then you can use that, and then you can like implement all those set of pieces as part of code that you have. Like you can have a VPC defined in there, a load balancer defined, a compute instances, multiple compute instances. They're auto scaling, a database and a link to them, the security groups for those compute instances. You can define everything in that template, and then you can use that to deploy it. So that is CloudFormation. So the answer here should be CloudFormation. The next question is, which AWS service can provide serverless computing? And I think they have highlighted serverless computing. But yeah, if they haven't, that should give it away by performing business logic without requiring an Amazon EC2 instance. So you're looking, they're talking about computing, and they're talking about serverless computing, and there's only one option which actually provides serverless computing in the computing world. So you should probably have it in your mind saying that this is the option. But if not, if you don't remember at this point, let's look at the options. Amazon Elastic Beanstalk. Amazon Elastic Beanstalk is a templated way where you can implement EC2 instances with the set of software that you need, that together bundled, so that you don't have to like set up your own EC2 instance and then choose what kind of Apache server you want on top of it, and what kind of connections you need, what kind of security groups you need. You don't have to choose all that and make your determinations. So you want to quickly set up an EC2 instance, which is needed for your, say, your web server to host WordPress. Then you can choose it from Elastic Beanstalk. It has a stack there, and then you can quickly deploy it. And Amazon S3 is a um, storage as a service, and you can use it for serverless storage for uh, images, text files, logs, those kind of things. I'll skip Amazon AWS Lambda for now, because it has to do with computing. It has to do with serverless computing. Probably is the answer, but let's look at the option 4. Step functions. Step functions are where you when you have to talk between applications for the communications, you use step functions. So it's not something that has to do with computing. So that can be eliminated as well. So even though Elastic Beanstalk is also something to do with um, computing, but it's not serverless. So the option has to be 3, AWS Lambda. So another question about EC2 instances: which AWS service provide disk storage for EC2 instances? So we when we went through storage, we looked at uh, two different storage devices which you can actually mount or load onto a EC2 instance. But if you don't remember what that is, like just go through the options. Amazon RDS, which is a database service for RDBMS. S3 is a serverless storage service. So number 3 is storage gateway. It's not a storage service in itself, but storage gateway helps like when you have hybrid computing, part of your data in your on-prem and part of your data in cloud. The storage gateway helps like move storage quickly between these networks. Amazon Elastic Block Store. This is something you can actually mount onto a EC2 instance, and it's local to that EC2 instance, and that can you can store data as a block store on this. This is in addition to the instance store. When you build the instance store, you build the EC2 instance, you can actually have a storage uh, like directly on the EC2 instance. The problem with that is like say if you like stop and restart it, or if you restart your EC2 instance, you might lose all the data. But Elastic Block Store, even if the EC2 instance goes down for some reason, the Elastic Block Store is still has the data persistent. So even if you're able to start another EC2 instance or able to restart the same EC2 instance, you can connect back to the Elastic Block Store and you still have all the data. So the option here is pretty clear, and it has to be Elastic Block Store. Another database question, or the database related questions are definitely going to be some with respect to RDBMS, some with respect to NoSQL databases. So let's look at this. This one is what database capabilities provided by Amazon Aurora. So Amazon Aurora is an RDBMS database that Amazon provides, and it's provided like in a few flavors, including MySQL flavor and PostgreSQL flavor. So you can choose that. But the promise that Amazon does is it is the server instances, the backup, everything is taken care of by Amazon. For example, all backup happens in a near real-time basis, like every few seconds, every few minutes. The data gets backed up onto a S3 bucket, and even if the Amazon Aurora instance is like down for some reason, you can always get the backup up to the almost uh, near time, and then get it back from S3 bucket. So you'll not be able to. I mean, you will not lose any data in case of any failures. And it also provides promise with respect to being much faster uh, than an than an than an RDS instance or a EC2 instance that you create and then you install MySQL on top of it. The Amazon Aurora is going to be much faster than that. So that's so those are the features of Aurora. So given that it has to be a relational database, it can't be a time series database. It can't be a NoSQL database. It can't be a graph database. Those options are listed here. So graph database that we have is Neptune in the Amazon AWS. The NoSQL database that they have is DynamoDB predominantly, but it could also be a document DB. Time series database is TimeStream. So those are our options. Which of the following pricing models provides the lowest cost storage in Amazon S3? So this is a bit of a confusing question. They're asking about which pricing model provides the lowest cost. So there are a lot of pricing models here: savings plans, standard storage, instant store, spot instances. So instant store is the storage connected to your EC2 instance. It's actually a hard disk or SSD that is connected to your EC2 instance, which is not really a pricing model. So I'm going to eliminate number 3. If you look at spot instances, the last option, those are something to do with cost as well. So you can reduce the cost by using spot instances. Savings plan is something where you can actually pay upfront or get an agreement to pay for 1 year or 3 years, so that you pay much lesser than what you would normally pay, up to 60% of savings. So it could be either of those if it weren't for the mention here about storage and S3. So here they're talking about storage and Amazon S3. So in S3, like you don't really have a savings plan. You don't really have any instances. So there are no EC2 instances to say spot instance could be one of the options. So we can eliminate 1 and 4 as well. So now we have left with only one option: standard storage. Typically, when you want to reduce cost, you go for something like a Glacier or a standard, like a infrequent access tier. So there are multiple tiers you go for, and standard storage would typically be the highest cost within S3 like costs. So I wouldn't choose standard storage if there are other options like Glacier or something like that. But because this question only has um, one relevant S3 bucket storage cost related item, so I have to choose standard storage for this. Let's look at an EC2 instance related question. Application is running EC2 instance on an Amazon EC2 instance, and it needs to access resources on S3. How can you assign permissions? So how will you assign permissions to the EC2 instance so that it can access the S3 bucket? So how do you do that? And if you know access, if you know how to provide access in AWS, you should always get it in your mind that it has to be an IAM related stuff. And within IAM, you could either get a role, or you could set up a IAM user. But in this instance, it's an easy to instance which has to connect, not a real user. So it makes sense for it to be a role. If you don't remember that, go back to the first video that we have, where I discussed between IAM users and IAM roles, and which, if it's a real person, would typically use a IAM user, and if it's a service, we have to use IAM role. And a person can take a role, the user can use a role if they're going to do something in a temporary basis. So they can uh, take a role for a temporary basis and do something. So typically users, if it's a person, then the person typically uses a user, and if it's a service or EC2 instance, then it takes a role. Sometimes a real person can take a role if it's temporary, but I've explained this pretty clearly in the first video. You can go back and look at that. So anything else that is mentioned here, like a MFA token, is actually used to authenticate someone who has like multi-factor authentication turned on, and if they have to authenticate using a password and using a token, then that's what that is. That's not something an EC2 instance can do. It doesn't use multi-factor authentication. It's a person logging in who would actually use a multi-factor authentication. Key pair seems like something related to security, but this is not something we do with the instance. It doesn't generate a key pair and then get used. The first option, identity federation to log into the instance, again, it seems like a security related option, but we don't really use identity federation. And they're talking about logging into the instance, not the instance having access to the S3 bucket. So it seems like um, okay, somebody could log in using identity federation, but how does that solve the issue of getting access to S3? So it's confusing, probably a partial answer. So I'm going to choose IAM role. That seems to be the right answer. The next is another compute related question. Which of the following compute services is good for workloads that only run for brief periods of time in response to infrequent events? So I'll get back to certain keywords that you need to remember to get certain answers. So, but before that, let's try to answer this question. So, three things that come out of this is it's a compute workload, and they're saying they run only for brief periods of time, so it doesn't run all the time, and it also it does it in response to some event that are infrequent. So it does it in a response to an event. So those are things that kind of give me the clue. For example, if something has to happen as a response to an event, then after an event happens, then that triggers something, and then for that period, that compute runs, and after that, the compute can stop running. It does not need to run. So if that is the case, I think we can fairly certainly say that it has to be like one of this. But say you're not able to make it out. Um, in my mind, I already made up my mind that it has to be one of this, and I'm able to see the answer and figure out what it is. But if not, let's go through the questions, the options here again. Amazon Elastic Container Service. This is where you have like the container system set up, and then like those are another computing service, but this is for Docker containers that you can set up, and then the Docker containers can have access to network and have its own application inside it, and the Docker containers can be scaled up, scaled down. So all those things you can do using Elastic Container Service. You can actually use that for compute service workloads, definitely. Um, you can use that to run for brief periods. So you can have a Elastic container running, and when you get more events, you can actually you can scale it up and have more Elastic, like more containers that spin up. And then when the volume of events is down, you can actually bring it down. So you can use this to do most of what question is asking for. Um, but whether this is the most ideal one, that's the question. So let's move on. AWS Lambda. Okay, this is a compute service as well. You can definitely use it for running brief periods of time, and you can use it in response to events. Like for example, somebody loads something on an S3 bucket, then it can call a Lambda function. The Lambda function can um, encrypt the file, or say zip the file and then put it back on S3. So Lambda function is able to do that. Um, so or you can set up an API gateway only when somebody calls the API gateway. You can do it on Lambda, but I think that's not what the question is asking for. They're asking about infrequent events. So AWS Lambda seems to be a good option. Let's keep reading on. Elastic Compute Cloud, which is actually the EC2 instance. Yeah, you can use EC2 instance. It is a compute service. You can run it for brief periods of time, and you can also have it like respond to an event and do the work. But is that ideal for running um, for brief periods of time? Because the other time when we're not actually using it, it will still be running. Um, so that is a question. So we'll come back to this as well. Cloudwatch. Cloudwatch is where you actually monitor your assets, your services. Like there's also Cloudwatch Logs where you could actually look at the logs. There's also a dashboard where you can set up your DynamoDB's performance, your the capacity that you have provisioned versus how much is used. You could set up all those things to be monitored as a graph. So all those can be done by CloudWatch. So it's not actually a compute service. So it doesn't make any sense for us to answer this question with CloudWatch. Let's eliminate that. So we have three other options here where EC2 instance, which I was very least convinced about, and I'm going to eliminate that as well because given the other two options, they are much more efficient in with respect to responding to infrequent events and to run for brief periods of time, because EC2 instance is going to run all the time, and you're going to like incur costs whether an event is happening or not. So I would rather use the other two. Let's go on to the other two. Within the other two, Elastic Container Service, even though you can scale it up and scale it down, even with the Elastic Container Service, you'll have to run at least one container that has to be running to run this application, and you might still be able to respond to the infrequent events, but the container is going to be running. At least one of the containers is going to be running. You may not need to scale up, but you may still have to have one of the containers running. Seems like that's also not the best option. You can do whatever they're asking with this, but it's not the best option for this. So you would rather choose AWS Lambda, which is a pretty good option for this. So before I go on to checking the answer, whenever you see AWS Lambda and you see things like serverless, you're pretty sure it's serverless computing, you're pretty sure it's going to be the AWS Lambda option. But if things like workloads that run for brief periods come up, or infrequent events come up, those are pretty close to like you're pretty close to being sure that it can be AWS Lambda. But say if AWS Lambda is not an option in those questions, then you can probably choose the next best one. So let's check our answer. It is AWS Lambda as we thought. The next one is next question is going to be about running multiple applications at a time. So your organization has multiple applications running on one AWS account. You've been asked to apportion the AWS cost by application. So this is a billing related question. What can you use to identify the costs related to each application? Yep. So whenever you set up an EC2 instance, like you can do certain thing that you can go back to Cost Explorer and then filter by that, or like report by that. So you can do that. So if you don't remember what that is, probably when you read the options in the answer, you should probably be able to figure it out. Let's look at those options that we have. First option is use multiple Amazon VPCs. Yep, you can definitely use multiple VPCs, but you don't need more than one VPC per region. So if you have one region and the whole region is covered by one VPC, that is ideal for most situations. Unless you have multi-region, we don't need to build another VPC network. Even if you do that, we'll have to connect between VPC to VPC using VPC peering. So it's a lot more things to do. But would that help us to actually report as different applications? Say application A, application B, and application C are what you have. Just because you have three different VPCs, does the Cost Explorer actually say, does it have an option to choose to report by VPCs? I don't think that's an option at all. So yeah, you can do it, and I don't see how that helps with the cost or apportion the cost to identify which application is costing what. So I'm going to strike off one. I'm going to skip past two just because I want to come back to it later. Number three is assign a different IAM role to each application. Yep, each application should have a different IAM role if it needs to have access to different databases or different resources, and that will typically be the case. You will definitely have different IAM roles. And depending on the application, and the IAM role gets assigned to pieces in the application. So the EC2 instances that run application A will have a certain IAM role, so not directly to the application. So that's another thing. Probably they are playing with the words here, but I'm not sure. So it could be assign a different IAM role to each application. But does that answer a question on billing? Does it help with apportioning the cost and identifying which application is costing what? I don't see any relevance here. So I see that it's a good thing to do. Assigning a different IAM role to each application is probably a good thing to do, but does not actually help us with identifying the cost. Purchasing reserved instances, again, a good thing to do. You can purchase a reserved instance whenever you know that you're going to use this system, similar instance for your company or for a longer time. Then you can purchase reserved instances and save in costs. But again, it's a good thing to do, but doesn't really tell me which application costs what. You can just save on costs. So I'll come back to two which I left off. Tag all resources. So if you remember, tag is a key value pair where you can tag your application A with application A, application B with application B, and application C with application C. When you go back to Cost Explorer, you just say, okay, report by application, and then it's going to throw out the different costs by application. So it has to be B. I think that's a easy one if you know what those things we covered during Cost Explorer. If not, you can go back to the Cost Explorer piece or go back to the EC2 instance which we're covering during the compute piece. Which tool enables you to visualize, understand, and manage your AWS costs and usage over time? So if you think about this, usage over time, this was one keyword I did mention when we were covering billing. So whenever you see the usage over time, I think you can easily remember what option it has to be. And if you see one of the options here, yeah, you're good to go. You know how to choose it, and you can just choose that and move on to the next question. But if you're not sure, let's read the other options, eliminate the rest of the ones. AWS Artifact. So AWS Artifact, if you know, this one is something where you can have two types of functionalities. You can check whether you have any agreements with AWS, and in the other functionality, you can actually check what happens, like what are the different documents or uh, compliance reports that AWS has with third parties. So any AWS related agreements and that you have, and any kind of reports, security and compliance that AWS has are there in AWS Artifact. Budgets, you can set a budget for each month, and you can monitor and see whether you're going to exceed it, you're forecasted to exceed it, or are you well within your budget. So you're setting a budget amount, and then checking whether you're going to exceed it or not. That's AWS budgets. Pricing calculators, where you don't have a system set up yet, but you're calculating something to estimate, create an estimate of your use case. So you have a use case, you want to like either build a new application, you need like 5 EC2 instances, a database, um, this kind of other infrastructures that you need. Then you can actually come up with what kind of pricing it would you would incur in that. So if you eliminate those three options, it can't be budgets, pricing calculator, or artifact. The answer has to be cost explorer. I'm pretty sure the answer marked here is wrong. So the answer has to be cost explorer. Which migration strategy involves changing how an application is architected and developed, typically by using cloud native features. So this was something we covered in our first session. Um, so this is this talks about cloud migration strategy. So cloud migration strategy is definitely going to be one of the topics that comes up during your exam. But this question is more about like using cloud native features. I think given that you're going to use cloud native features, that kind of gives the question away, the answer away. Rehosting is where whatever you're hosting on your uh, like on your on-prem, you just don't rewrite the application, don't do anything, any kind of rework, just host it, the whole infrastructure over on AWS is called rehosting. Replatforming is where you kind of uh, take the code out and then move it into AWS without rewriting it. But if you have a database that's in Oracle, you can use an RDS database, so you don't have to set up the whole server. So you kind of re-platform it, you kind of pick it up and then move it into AWS. You don't completely rehost everything. You don't exactly replicate whatever you're doing in rehosting, but you kind of do some kind of move and shift with re-platforming. Refactoring is where you figure out, okay, this is a service that cloud provides much better, so we can actually use the benefits of the cloud, and then rewrite certain aspects of your application or re-architect certain aspects of your application. For instance, if you have a database that is like on Oracle on your system, and if you want that information to be available um, at the cache, like everywhere, then you can refactor the application such that in addition to the Oracle application, certain elements of the database that are frequently accessed can be part of the Amazon Elastic Cache, and you can build the Oracle application on an RDS, and you can rewrite the code so that you can pull some of the information from Elasticache, and you can also make sure your application can be like agile, while in your earlier aspect it might have been um, using a waterfall model, and you might have to make code changes at a much smaller fashion. You might start using microservices architecture when you move on to AWS Cloud. So if you do those kind of architecture changes, code changes, those are called refactoring, which again, if you read the question again, I think probably what the answer is. And then repurchasing is where I don't know if that's a migration strategy itself. So probably not the answer. So I'm going to choose refactoring. So if you see repurchasing, okay, uh, it is something, but I don't think it's a migration strategy. I'm sorry, it is a migration strategy. Repurchasing involves replacing an existing application with a cloud-based version, uh, such as software found in AWS Marketplace. So if you find a software that replaces your um, current functionality of your application, then you can just replace that by purchasing another software. Yeah, you could go to AWS Marketplace, or you could buy it based on another place as well. Rehosting is where you move the application. It's also known as lift and shift. Replatforming is called lift, tinker, and shift. So you move, you don't change the core architecture of the application, but you optimize so that you get some benefits. So refactoring should be our answer here. Okay. You want Amazon S3 to monitor your object's access patterns. Which storage class should you use? Should you use the intelligent tiering, one zone infrequent access, the Glacier, or the standard infrequent access? Because you want to, if you notice what this is, like all these are tiers that storage class tiers that we can actually use, um, and one zone into infrequent access is where your data is stored only in one zone, not in all availability zones, but you know your data is going to be infrequently accessed. Uh, so you, because you're infrequently accessing it and you're putting it in the right storage class, you'll pay less for it. The S3 Glacier um, is the cheapest option available. You store for pretty much very low money. Um, but it doesn't really monitor your object's access patterns. So to monitor and change your objects from one tier to another, you actually use something called S3 intelligent tiering. So that should be an answer. So let's look at that. Description for S3 Glacier is a low-cost storage. It is ideal for data archiving. Um, if you need access to your data that you stored, it may take you a few minutes to a few hours to access to the data. S3 standard IA storage is for infrequently accessed data, um, which you need, but um, it's stored in multiple availability zones so that you don't lose access to your data for any reason of like a disaster or something like that. One zone IA is for infrequent access data, but you don't really need high availability. You don't need like you're okay to live without the data for some time whenever there's a disaster. And intelligent tiering is when you haven't accessed it for 30 days continuously. Amazon S3 moves it directly from standard uh, to a standard IA. And if it's in standard IA and then somebody accesses the data, then it automatically moves it back to the S3 standard. So you move it back between S3 standard and S3 standard IA. And Amazon S3 monitors this for 30 days. If you haven't touched it and it's in S3, it moves it to S3 standard IA. And if somebody touches it, that means it's somebody starting to use it, then it moves it back to S3 standard. So the option here has to be S3 intelligent tiering. You're running an Amazon EC2 instance and want to store data in an attached resource. The data is temporary and will not be kept long term. Which resource should you use? So you know that your data is going to be temporary. You know that you want to store data in an attached resource. So we know it can't be an S3 bucket. S3 bucket is not really attached to any EC2 instance. It's a serverless storage of data. So it can't be number two. Subnet is more of a networking related thing. We looked at it in detail in the last session. Um, um, like within a VPC, you can have multiple subnets, and a subnet can't go beyond an availability zone. So if you have like one subnet, uh, it cannot be across two or more multiple availability zones. It has to be within an availability zone. So that's a subnet. It has nothing to do with storage. It has nothing to do with data. It has nothing to do with any of those. So can't be uh, that as well. It has to be either the instance store, which is the first option, or the fourth option, which is Amazon Elastic Block Storage. But we should look back at the question to understand the clues which let us know whether it's going to be the Elastic Block Store or the instance store. We are talking about an attached resource. Yeah, you can attach an EBS to the EC2 instance, or the instance store that comes along with the EC2 instance when you set it up is attached to your EC2 instance. So both of them do answer that part of the question. The next part of the question says your data is temporary and will not be kept long term. So when the EC2 instance is shut off, you don't really need access to it. It's actually temporary, and you don't really need to store it long term. Say you want to bring up another EC2 instance and you want to attach this EBS volume to it, you don't have to do that. So given all that, I think it's pretty clear that this has to be the instance store. So when you stop a EC2 instance, the data that's been written to an instance store is also deleted. So when you stop it or terminate it, the whole data that has been attached to the instance store is also deleted. EBS volumes, though, they're ideal for data that's retained. So if you are, even after stopping, terminating, you still want the data to persist, then you use EBS volume. Uh, like the data in that volume is still available. S3 bucket, we definitely know that it cannot be attached to an EC2 instance. Subnet is a section of the VPC cloud, and you can group the resources based on security or operational needs. So if there are 10 things in your region within an availability zone that have the same security needs, operational needs, then you put them within a subnet together, and then you can have the same routing rules and the same access rules for them. So instance store is the right option here. Let's move on to the next question. Which action can you perform in Amazon CloudFront? We saw this today. The CloudFront is certain things you remember with CloudFront are edge locations, worldwide access, and the files are cached in the edge locations, so people can access it much quicker. So those things come to mind when you read Amazon CloudFront. Now let me go through the options. Run infrastructure in a hybrid cloud approach. Nothing related to hybrid cloud, which is like on-prem and cloud, that is relevant to CloudFront. You can do it hybrid cloud or on-prem. It doesn't make a difference. Um, Provision an isolated section of AWS Cloud to launch resources in a virtual network that you define. Again, it's not an isolated section. The isolated section gives me an idea of something else. A vault section within a network that we always spoke about, which is a different keyword here, not this. That's actually VPC. So the first one, the run infrastructure in a hybrid cloud approach, it's actually an AWS Outposts. This one, provision isolated section. So I've spoken about this a lot of times. Walled section within AWS Cloud, where you have your own access to your own network. That's called a VPC network. Deliver content to customers through a global network at edge locations seems to be our answer. Let's move on and check the last option and make sure that's not our answer. Provision resources by using programming languages or text file. Okay, so this one is CloudFormation. Again, one very frequently asked option or a question about this CloudFormation. So noted. like if you want to do infrastructure as a code, that is, you write a quick like text file as a JSON or a Jinja file, and then you using that you provision some resources, including you have a set of EC2 instances that auto scale, that have these security groups. They connect to these databases. You want to set up certain databases. You want to set up a network with it. You want to do everything. Then you write everything together in a one file, and then with that you can provision the whole set of codes. With Amazon CLI, you can do them one by one, so you can provision them one by one. But if with using CloudFormation, you can do the whole environment together. You can provision all the resources, all the infrastructure that you need together in one go. So yeah, the question here I think is pretty obvious. You have to go back to the option 3, and that's right. Your next question is you want to store data in key value database. What service should you use? Again, as soon as you hear the word key value database, you probably can make it out. So you probably know what the answer is. I can make it out here, but let me read the other options. Amazon RDS, which is a relative RDBMS, so it's a relational database. Amazon Aurora, another relational database. Amazon Document DB, which is a MongoDB related database. Amazon DynamoDB, which is a key value database, so it has to be an answer. So let's hit that. That's good. S3. So S3 is again you'll get 2 to 3 questions for sure from S3. So if you know your S3 questions very well, the different storage classes, you'll be pretty good about at least those 2 to 3 questions. You'll get those right. In the S3 intelligent tiering storage class, Amazon S3 moves objects between a frequent access tier and an infrequent access tier. Which storage classes are used? Which do they move them from? I think we saw this a couple of questions ago or a few questions ago. It moves it from S3 standard to S3 one zone infrequent access. Or sorry, S3 standard infrequent access. So the options here are 1 and 5. Yeah, you have to select 2 answers here. So it moves it between standard, and if it's not accessed for 30 days, in standard, so nobody has actually accessed it, then it moves it to infrequent access. Say 6 months later, somebody accesses it, and then it goes back to S3 standard and stays there for 30 days until unless somebody keeps accessing it, so it stays on standard. But if nobody accesses it for the next 30 days, it moves back to S3 standard again. So that is what the 2 tiers that get transferred between are. What a statement best describes an availability zone? Okay, this one I was pretty stumped with. I at first I got it wrong, but then I saw AWS's explanation for this. To actually understand it, I had to read it like a couple of times before I understood how AWS explained this. Which statement best describes an availability zone? A separate geographical region with multiple locations that are isolated from each other. Note that it says isolated from each other, and that's the piece I think I missed to really get. And the next one is a fully isolated portion of the AWS global infrastructure. Again, here isolated portion. So this should give you the answer of like, okay, what we're getting to. Next one is the site that Amazon Cloudfront uses to cache copies of content for faster delivery to users at any location. These are edge locations, nothing to do with availability zones. The map of AWS has a list of regions, availability zones, and edge locations, and you can see that like each region has multiple availability zones, and the edge locations are not really related to like these. The last option there, so I'm going to strike off number 3. It's definitely edge location, whatever that's described there. Number 4 is the server from which CloudFront gets your files. Again, availability zone has nothing to do with CloudFront. They're talking about the server, which is not an availability zone. Availability zone is is a set of um, um, is either one separate um, server center, or how do I call it, a, a, a place where you have all your servers and all your data is hosted there. That location, and you have multiple such locations, data centers. So those together, if they're isolated from the other um, such availability centers, such as they have different electricity networks, different networking companies, so they have different infrastructure, then that is an availability zone. So given that, it has to be option 2, because it talks about a fully isolated portion of AWS global infrastructure, while the number 1 is actually a zone, is actually a region where it talks about a separate geographic location with multiple locations that are isolated from each other. So it has to be number 2. We'll go on to the next question. This talks about VPC. Which component or service enables you to establish a dedicated private connection between your data center and virtual private cloud? So we spoke about this when we spoke about networking. Dedicated private connection should give it away. So when we looked at it, we said, okay, whenever you see dedicated private connection, it has to be this. So it does give it away. So let's look at the other options: Cloudfront, Internet Gateway, Direct Connect, Virtual Private Gateway. So Cloudfront, if you know what that is, it's a content delivery service. It uses a network of edge locations to cache the content and deliver the content worldwide. Internet Gateway is where if you want to expose your subnet to the internet, then you provide the internet gateway. So that's on your routing table. You provide access for the internet gateway to ingress or egress. So people like connections from outside world through the internet can come into the subnet, and connections from the subnet can go outside the world to the through the internet gateway. So that's a connection between the VPC and the internet. So if you want to connect that, you need an internet gateway. Let's skip AWS Direct Connect for the reasons that I think that must be the answer. Let's look at what virtual private gateway is. Again, that's similar to an internet gateway where you have access to the VPC gets access to the internet, or the internet gets access to get into the VPC. Virtual private gateway is where a corporate network gets connection to your VPC network. So your it allows a VPN connection between your VPC network and your private network. So this one, it goes through the internet, but it goes through a VPN tunnel, which is completely encrypted. But it's not direct connect is much more secure than VPN, and is much more faster. It's a dedicated private connection. So the option that we have to choose is direct connect, and because the question says dedicated private connection between your data center and virtual private cloud, it has to be direct connect. And if you remember, we spoke about how a cable directly goes from your data center to a co-located third party or AWS server. So there is a physical wire that goes through, and then it connects them. So you don't really go through the internet to actually connect to an AWS infrastructure. So you directly connect from your network through a physical wire to an AWS server. Which compute option reduces cost when you commit to a consistent amount of compute usage for 1 or a 3-year term? So I think with your with our multiple sessions, we did cover this. We spoke about the savings plan, which when you commit to a 1-year or 3-year term, you get the benefit. We do get confused with, obviously, spot instances are for workloads that can run at a flexible time and can be stopped and started. Not for business critical workloads, not for critical workloads that have to run at a particular certain time and have to finish before a certain time. We know that. We know what a dedicated host is. Dedicated host is a much more expensive option for a compute EC2 instance, where you get a dedicated instance. I'm sorry, dedicated hosts probably is different from dedicated instances. Um, Probably not what I was thinking of. So dedicated hosts are different. There's nothing to do with compute. And this reserved instances is the only thing you could get confused with. But in reserved instances, you do commit to a consistent amount of compute usage, but you don't do it based on dollar amount, and you don't do it based on you actually do it based on what type of instance that you reserve. Is it going to be a Linux instance? Is it going to be uh, uh, a compute efficient one? Is it going to be like this much RAM? Is it going to be this much hard disk? That's what it is. So it has to be the savings plan. Which virtual private cloud component controls inbound and outbound traffic for EC2 instances? So for EC2 instances, we covered this yesterday when we covered security. So whenever we talk about EC2 instances, um, each EC2 instance should have a firewall, and that firewall is called one of the options here. And if you don't know that, we can eliminate the other options and figure it out. Um, and a subnet has another firewall, which is actually a network access control list. So that firewall that the subnet has, like, is the first level of defense. And after it's able to get into the network access control list, it still has to fall within the rules of the security group for a connection from the outside world to come into a EC2 instance. Um, so yeah, I mean, the answer here is security group, but the other options here are network access control list, which is also something that controls inbound and outbound traffic, but it does it at a subnet level, not at the instance level. So given that it clearly says that it's at the instance level, so we can make sure it has to be the security group. What is internet gateway again? We saw that it's the gateway that allows your subnet or your VPC to connect to the internet. So we without the gateway, the subnet would be a if you don't have the internet gateway listed on your routing table of your subnet, that particular subnet would become a private subnet, and it's not a public subnet where it can actually have access to the internet. And subnet is a part of the VPC. It does it's just a list of IP addresses or a range of IP addresses that you uh, gather together, and we can set up like a similar network access control list for all the like EC2 instances or databases that get defined within that subnet. So the answer here has to be security group. I think it's pretty easy to choose when as long as you know all the concepts. Which service is used to quickly deploy and scale applications on AWS? Outposts, Cloudfront, Elastic Beanstalk, and Snowball. Let's look at the options one by one. Outposts help you run infrastructure in a hybrid cloud approach. So if you have on-prem and cloud, and you want to run a cloud hybrid cloud approach, then you use Outposts. Cloudfront, we have seen this multiple times: edge locations, content delivery. Elastic Beanstalk, again, this is the answer here, but let's look at why it's not Snowball, and then we'll come back here. Snowball is actually a physical device that AWS ships to you. You transfer your data, and then you get all the data back to AWS. You ship it physically, and then you get it back there. Elastic Beanstalk should be the answer here, because if you remember, if you want to deploy a set of software along with your so we always spoke about the WordPress example. So if you want to set up a WordPress um, um, system where you need a LAMP system beneath it, and then you need a WordPress software on top of it. So to set up that LAMP server, you need to set up a couple of EC2 instances. You have to set up a database. You will have to set up like a MySQL database, Apache server on top of it. On all those EC2 instances, you need to auto scale them. You need to set up all those things. But with Elastic Beanstalk, all that can be done with a few clicks, and like Elastic Beanstalk already has certain configurations that you can it can automatically set up your subnet, your um, like security groups. It can set up your VPC. It can do everything within with the first set of Elastic Beanstalk clicks. So that is the one that you can quickly deploy, and you can scale applications. It has auto scaling as well, so that if you're not sure why we are able to scale applications, Elastic Beanstalk not only contains security groups, VPC networks, your EC2 instance settings, it also has auto scaling settings. Which tool can be used to automate actions for AWS services and applications through scripts? So you want to write a script and you want to automate your um, um, like launching a EC2 instance. So you write a script where like you open the AWS. I shouldn't say the answer here, but you open this tool and then you type in a script and then it launches the EC2 instance. Which tool can you use to actually automate these? Redshift does not seem like it. It's a data warehousing tool that you use for big data analytics. Snowball, again, we just saw it earlier. It was a physical device. The QLDB is a ledger database, pretty common among the questions here. So if you don't remember, just revise this. It's a ledger database. The data is immutable, so somebody cannot go and change the data. There's no update statement here, so you can't go and delete or update data that is already there. So anything that happens stays there, and the history of that stays there as well. And the biggest advantage of this is you can use it for any kind of Bitcoin or um, cryptocurrency or any type of cryptocurrency related, blockchain related uses. And because you can't delete the data or update the data, you can have a complete history of all the changes that have been made to your application data. So you can have all that in a QLDB or a quantum ledger database. So the answer here is the command line interface. CLI tool is pretty useful. At first, when you get into AWS, you might use the web interface, but believe me, after some time, it's pretty easier, pretty much easier to run a quick command on CLI. Store that command in your notepad or your OneNote, and then uh, run it again whenever you need to launch another instance, which is similar. And then if you want to change a few parameters, you just change it on the command line interface on the command itself, and then run the command again. So it's much easier and you use it pretty often. And yeah, that's the definition of snowball. Which statement best describes Amazon guard duty? So the guard duty is one of the things we covered pretty much in the first or second session, and it's a tool that helps with like vulnerabilities, threat detection. So let's look at some of the confusing options here and then try to figure out what is what. First one is a service that lets you monitor network requests that come into your web application. So if you want to monitor any network requests that come in to your web applications, so those are those are keywords that tell you that it's a WAF or a web application framework. So next one is a service that helps you protect against distributed denial of service. So DDoS attacks. Again, if you know the DDoS attacks, then you know. Okay, so let's look at the last option here. So some reason the last option here is security that checks a service that checks applications for security vulnerabilities and deviations from security best practices. So Amazon Inspector is the one that helps with checking security vulnerabilities and like, are you deviating from any of the security best practices? Amazon Inspector does that for you. Amazon Shield does protecting any kind of protection against distributed denial of service or DDoS attacks. And our answer has to be for guard duty. It provides threat detection of your infrastructure and resources. So any kind of infrastructure threats that you have, guard duty monitors on a regular basis, and it provides intelligent threat detection. So you don't have to go in there and check it. You get the information as a notification. Okay, so those are the questions that I've compiled for today. This should get you through the exam. Just a few tips to get you to answer the questions like well. Obviously, prepare, use these 10 sessions, watch the videos again. I'll provide links for each of the sessions below in the description so that you can look at what additional reading you can do in case you want to read a bit more. But these 10 videos should cover you completely for getting through this exam. But to actually go through the exam, a few pointers here: read the question fully. Sometimes you might read a part of it and you might want to quickly answer it, but sometimes like AWS wants you to like be very selective, and they might have some confusing aspects in your question. One keyword that kind of changes why you would choose that. So read the question in full before you even try reading the answers. Before you even read the answers, predict what answer it's going to be. So if you read something called serverless computing, so you predict in your mind that it has to be Lambda before you even look at the options. After you look at the options, and if it's not pretty straightforward, start eliminating the incorrect response options. Okay, this definitely cannot be the answer. This definitely cannot be the answer. So do that and eliminate the incorrect response options. That should get you to answer all the right questions. Your score ranges are typically from 100 to 1000. 700, if you clear 700, you pass the exam. Exam has 65 questions and you have 90 minutes, an hour and a half to complete it. The passing score is 70%. There are two types of questions. One is a multiple choice, and it could also be select two of the following or select three of the following. So that's a multiple response option. So the multiple choice, so if you want to guess, if you're not sure of the answer, please go ahead and guess. There's no penalty, there's no negative marking, there's no penalty for guessing. So don't leave any question unanswered. And I'm going to link those overview of web services, pricing, and AWS support plan related links below. And in each of these 10 sessions, I'll add any kind of useful links from AWS that you can go through. I'm also going to put in the Cloud Practitioner Exam guide that AWS provides. I'm going to link that as well in the description below in today's session's description. So go ahead and take a look at that before you write the exam. Look at the Cloud Practitioner Exam guide that AWS provides, and make sure you read everything and say, oh yeah, this I'm pretty sure about, this I'm pretty sure about. So if you make a note of anything that you're not very confident about, then you can either come back and look at these videos, or you can go and do an additional reading from AWS's materials to understand what is the right answer. Thank you so much. All the best to your exam.